Okay, in this video I'm going to be solving these three integrals from the MIT Integration Bee from 2006. I was watching it the other night and I thought it was really interesting, so I just decided to solve some of the problems, and I picked these out to solve in this video. These first two were actually the first integrals in the competition, and they can actually be solved using the same technique, and I found that it was easiest to solve them using trig substitution, so I'll be showing how I did that. And then this last integral, you can manipulate this with some algebra and some trig identities to make it easier to solve, so I will be going through all of these and showing you how I solved them. So for solving this integral, at first glance it looks like it's pretty difficult to solve, and when I was watching the competition, the first two contestants both tried to manipulate this and use some form of a u substitution, which when I first tried solving this integral I did the same thing, and it ends up being like super confusing, and so I ditched that technique and decided to try a trig substitution, and that worked out much better and it was much easier to solve that way. If you're unfamiliar, trig substitution is a technique of integration. Here in the US, you usually learn it in Calculus 2 in college. So I am going to be using that to solve this integral. So with trig substitution, in this denominator, the goal here is to substitute something in for x so that we can get the expression 1 minus sine squared theta, and that will enable us to substitute 1 minus sine squared theta with cosine squared theta. And once you get to cosine squared theta in this denominator, it becomes much easier to solve. Things start canceling out, and you'll see that as I progress through this problem. So in order to do that, I need to set my x equal. So we have x cubed. If I want sine squared here, I need to plug in sine to the 2/3 theta. So when I cube it, once it's placed in there, it'll become sine squared theta. Then I need to take the derivative of this, which will be 2/3 sine to the negative 1/3 theta multiplied by the derivative of sine, which is cosine theta. That's using chain rule there. Okay, once I'm here, I can just make these substitutions. And then I will substitute dx with this entire expression, which is going to start simplifying. All right, now when we get to this point, we can see that our cosines cancel or simplify to 1. Sine 2/3 theta, sine raised to the 2/3 theta raised to the 1/2 is just going to be sine 1/3 theta. And then we have sine to the negative 1/3 theta, which we can bring down into the denominator. And I can see that these will simplify to 1. And once we get to this point, this integral is super easy to solve. So we just get 2/3 theta plus c. Okay, now that we're here, the only thing we have left to do is replacing our theta. So our original substitution that we made was x equals sine raised to the 2/3 theta. And now we just need to solve for theta. So first I'm going to raise both sides to the 3/2. And to solve for theta now, we just need to take the sine inverse or the arcsine of both sides. And we can plug that in now. So our entire integral from the beginning, x over 1 minus x cubed dx is equal to, plugging in right here, 2/3 theta is arc sine of x to the 3/2 plus c. And that's our final answer. Okay, so the next example, which was the integral of x to the -1/2 over 1 plus x to the 1/3 dx. I think that was the integral. Yes. Okay, so we're going to use the same technique, which is trig substitution, but in the denominator, I want to substitute something in for x so that I have 1 plus tangent squared theta equals secant squared theta. So for x, I'm going to substitute in tangent of 6 theta, which once we plug it in will give us tan squared theta. And I'm going to take the derivative of that, which is 6 tangent theta to the 5th times the derivative of tangent, which is secant squared theta. Okay, we're going to start substituting these in. Now for tangent squared theta, it's easier if you use this. Identity again to make another substitution to finish out this integral. So tangent squared theta is equal to secant squared theta minus 1 d theta, which it's really easy to take the integral of secant squared theta. It's just tangent. So here we just have tangent theta minus theta plus c. Again, all we need to do now is substitute back in for our theta. Our original substitution was that x equals tangent of theta to the 6th power. So we are going to raise both sides to the 1/6. So we get tangent theta is equal to x to the 1/6, and then take the inverse or arctangent of both sides. And then we'll plug this back in to our final, into here. Okay, and last but not least, let's solve this last integral that I picked out. All we're going to do with this is work with this, manipulate it a little bit, and get it to a place that's easier to solve. So the first thing I'm going to do is multiply the top and bottom by 1 minus sine x, which is the equivalent of multiplying by 1, so it's totally fair to do. Doing that, I'm going to get 1 minus 2 sine of x plus sine squared of x in the numerator. The denominator will be 1 minus sine squared x, which is convenient because we can use this identity again. Cosine squared x. Okay, I'm going to separate this. So I have 1 over cosine squared x minus cosine squared x. Okay, and then I'll divide these into their own little integrals. So 1 over cosine squared x is equivalent to secant squared x dx minus, bring this 2 out in front of the integral sign. Sine over cosine is tangent of x, and then we have 1 over cosine remaining since we have cosine squared x in the bottom there, so that is secant x dx plus the integral of sine squared x over cosine squared x, which is equivalent to tangent of x. All right, so the integral of secant squared x is tangent. The integral of tangent secant is just secant. And then I'm going to use that identity again here, make this integral easier to solve. We'll have secant squared x minus 1. Integral of secant squared again is tangent minus x. Okay, and we can simplify this one more step. We have 2 tangents here, so we have 2 tan x minus 2 secant x minus x plus c, which is our answer. Okay, so I thought those integrals were pretty interesting and fun to solve. I hope you thought so too. You can subscribe to this channel for more math content, and I will see you in my next video.